Ever wondered how a processor actually works? Today we're diving deep into the 3 fundamental instruction sets that power every modern processor. Whether it's Intel, AMD, or ARM, they all follow these core principles. Let's unlock the digital architect's toolkit. Think about it. How do ones and zeros transform into the apps you use every day? The answer lies in understanding how processors execute instructions. Let's break down this fascinating journey, from pure logic to living applications. Meet the processor, the master builder of the digital world. From Intel Pentium to AMD Ryzen, every processor is designed to execute commands, not think. It follows a precise set of instructions, called the instruction set. This is what gives the processor its power. Just like a carpenter needs different tools, a processor needs different types of instructions. These are organized into 3 essential categories that form the complete instruction set. Each category has a specific role in making your programs run. First up, data transfer instructions. These are the foundation. They move information between the processor's registers, memory, and input-output devices. Think of it as the logistics system. Nothing happens without moving data to the right place first. Here are the key commands. Load brings data from memory into registers, store saves it back, move transfers between registers, and push-pop handle stack operations. These 4 operations are the backbone of data movement in any program. Once data is in place, we need to transform it. Data manipulation instructions are the power tools. They change, calculate, and transform data. This is where the actual computational work happens inside the processor. Data manipulation has 3 types: arithmetic operations like add, subtract, multiply, and divide. Logical operations like AND, OR, and XOR for bit-level manipulation, and shift operations that move bits left or right, essential for efficient calculations. Let's see them in action. Arithmetic. 5 plus 3 equals 8. Logical operations work at the bit level, and activates only when both bits are 1. OR activates when either is 1. These operations are fundamental to every calculation your processor performs. But programs aren't just linear lists. They have flow. Program control instructions direct the sequence of execution. They enable decisions, loops, and function calls. This is what makes programs intelligent and dynamic. 3 key types here. Jump or branch changes execution to a different location based on conditions, like your if statements. Call and return manage subroutines and functions. And skip instructions allow conditional execution, jumping over code when needed. Here's the magic. All 3 work together. Take this simple for loop. We load the value of I using data transfer. We check the condition using program control. We increment I using data manipulation. Every single line of code uses this seamless combination of all 3 instruction types. Now here's the interesting part. While these 3 categories are fundamental to all processors, Intel x86, AMD, and ARM each implement them with their own unique instruction sets. The principles remain the same, but the execution varies. That's what makes each architecture special. And that's it. From 3 simple roles, moving data, changing data, and controlling flow, every piece of software is built. Understanding these instruction sets is understanding how computers truly work at the lowest level. If you found this helpful, drop a like and subscribe for more deep dives into computer architecture.